The next video pertained to these notes here, methods 2. So let me pull those up. And I've titled this one More with Methods. And we're going to talk more about parameter passing and dive a little deeper into this concept of reference versus value types of variables, or maybe I should say, in this case, reference versus value types of parameters. And we're going to mix our use of methods with array processing. And as it says here, this corresponds with both chapters 6 and 7. And in particular, I'm going to compare a couple of programs, a couple of Java classes, one that's in chapter 6 against another one that's in chapter 7. And if you look in your Lang 11e samples, you'll see that in chapter 6, there's a class called TestPassByValue. And in chapter 7, there's another class called TestPassArray. In both cases, they're performing a kind of a task which is swapping two values, one that's in one variable and another that's in another variable, and swapping them. And you see the effects of it in both of those cases. But there's a slight difference in the second case, because in the first case, they're just swapping two scalar integer values. But in the second case, they're swapping two elements of an array. And we're going to see some of the implications of A, the notion of pass by value, and B, what happens when the value that you are passing is a reference instead of a value, a primitive data type. So again, let's remind ourselves, there is such a thing as pass by reference, but it does not exist in Java. Pass by reference, the formal parameter and the actual parameter are actually one and the same thing. So changing the content of the formal parameter also changes the actual parameter. But we don't have that in Java. It's strictly pass by value. However, as I'm alluding to, you might be passing references. So let's take a look at the class that's in chapter 6. It's called TestPassByValue, and it has a main method, and it has the swap method. And as you can see, the formal parameters for the swap method are these two. Let's kind of look again at the anatomy of such a thing. And here's, by the way, before we look at the anatomy, here's, by the way, what you have to do if you're going to swap two values. You have to have an additional temporary variable. I can't just say n1 equal n2 and then n2 equal n1, because by that time n1 has changed. So I have to take n1, I have to put it into a temporary variable, then I take n2 and put it into n1, and then I take my temporary and put it into n2. Very, very common swapping kind of thing that takes place in all kinds of programming. So now let's look at the anatomy again of the method call and the declaration. And the method call, here is our declaration. We got our modifiers, public and static. So here we got two modifiers here. Again, we have to talk about what public means and what static means later. Static, everything we've done has been static. And as I've said before, we're going to be doing stuff with non-static. And public means it's visibly accessible from outside the class. And we'll talk about things like public and private and protected, which are visibility modifiers later on. And then here's the return type. So this is a void. So this is not a method that returns a value. So I guess I wouldn't personally call that a function. I'd probably call it more of a procedure or a subroutine. And then here's the name, the identifier, and the two formal parameters. Again, these are basically like variable declarations. Two integers is taken. One is going to take in, it's going to consider it to be n1, and the other is going to take in, it's considered to n2. It does the method body is executing the code, and you really don't need a return statement for this. And here's the call. So again, it's specifying the identifier. Remember the distinction between actual parameters versus formal parameters. The actual parameter is data. Formal parameter isn't data until it receives something. A formal parameter is a specification. What does it expect to receive? The actual parameter is real data. That means it could be a literal, it could be the contents of a variable or a constant, it could be some kind of an expression that returns a value. That could even be what gets passed as an argument to this swap. We could even have another method call that get passed as an argument to the swap. As a matter of fact, you saw something like that with the method overloading, where we had one max method that took 3 arguments, and then it would call the other max method that took 2 arguments in order to deal with that argument. So going back and take a look at it. And notice that because we're not returning a value, there's no return statement. There could be a return statement, but you can't be returning a value of a particular type because this is a void. Because of that, there's not going to be, this is not an expression. Swap num1, num2, that's not an expression. It's just basically a set of instructions that execute. They do something, they have an effect, but there's no data that's being returned. And here's the sequencing again. Blah, blah, same thing as before. So now I'd like to again reemphasize the distinction between value variables and reference variables. The only kinds of variables that are value variables are those that are primitive data types, that are scalar, that means single variables of a primitive data type. Everything else is a reference, which means it's pointing to something on the heap, or possibly to something in the constants pool. So therefore now, where we had been in the previous methods notes, we had been focusing only on the stack, on the frame stack. Now we're also going to be looking at the heap as well. We won't be looking at the heap in this example, but we will in the next example. So let's take a look at what's happening in main before we call. So here we are. Let's say the breakpoint had been right here. By that time, we have num1 and num2. They've been initialized. As a matter of fact, if we saw the screen, we would have already seen this statement coming out, this print coming out. And then here's our swap taking place. And what happens? Control goes to swap, right? And what happens also is that swap's frame is placed on the stack. So it has an N1 and N2 right here. This one had num1 and num2. So the num1 and num2 are in the scope of main. Here's their values. Those actual parameters, copies of that, were placed here. We do the swap. There's a swap taking place. So let's go back here. Let's take a look and see what's happening in here. So we've got now, we have put the value in N1 in the temp. We've taken N2 and put it in N1, but fortunately we didn't lose that original value because it's in temp, and finally we're able to do the swap. We do the swap. If the print takes place, it's going to say, you know, they're swapped. But the actual parameters have not changed. Nothing has happened to num1 and num2. They're still the same. So therefore, the original arguments never changed, and this print is going to say they're still the same. So let's take a look at it in NetBeans. So here is the code for this test pass by value. Let me just run it. And there you have it. The original num1 and num2 did not change. Now, I encourage you to put breakpoints where we had talked about. I'm not going to do it. I think you can do it on your own. You get a flavor for what's taking place. So in the previous example, the parameters were primitive data. In other words, they were scalar integers, and scalar meaning single value, not an array, not a collection, single value. Scalar, S-C-A-L-A-R is the spelling. And the formal parameters were specified that same way. And we saw the illustration of pass by value. But now we're going to take a look and see what happens if the parameters are references. And specifically, we're going to look at an array, although the same principle is going to be true when we start looking at objects. instances of classes would be the same thing taking place. So therefore, even though the parameter itself does not change, the result of the data does change. So we're going to look at an array that's being pointed at basically by multiple places, as we'll see. So let's take a look first and run it real quick. This is the one from chapter 7, TestPassArray. And let me run this one. So here's before invoking the swap. And here's after invoking the swap. This is the same thing. We actually have two things here. We have swap, this original swap, and then we have this swap first two things in array. So this was a swap which was just like what we had before. And this is the swap first two in array where we're going to actually be passing an array instead of two separate integer values. So in the original swap, nothing changed. But when we're using swap first to an array, the change becomes permanent. So let's take a look and see what happened. So here's our code. We've got our main method. Our main method has created an array. We've instantiated an array. It's just two elements. And we've got some prints saying what the values are before and after we've done the swap. And we've got some prints saying what happened before and after we did this other method. And here's the one method, swap first to an array, which takes a single formal parameter, which would be a reference to an array. And here's the other one, which this is exactly what we had before. So let's take a look and see what's happening as this code is executing. So first, we're going to have this declaration of a variable and an instantiation of an array, an assignment of the reference to the array into the variable. So here we have our declaration. Now we have this variable called A. If all we had done was declared A, we have not created an array here. As a matter of fact, if all we had said was int square brackets A semicolon, and then we went to the next line of the code and we looked at what A contained, it would be null. It would have nothing in it. It would be null. It would literally show up as null, N-U-L-L, in the debugger. So now we're creating the array. So now we have an array on the heap. And then the assignment operator makes the variable point to the array. I had shown you that when we talked about arrays before. And now we're calling swap. So what are we passing as arguments here? We're passing one element and we're passing another element. These are our actual parameters. So a copy of what's in element 0 of A is going to be taken in as N1. And a copy of what's in element 1 of A is going to be taken in as N2, which means a copy of this one is going in there, and a copy of that 2 is going in there. And we go through the swap, blah-de-blah, 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 nothing changes. Now let's contrast that with when we call the other method. So here's our method called to swap first to an array, and what we're passing is A. Well, what's A? What's the contents of A? The contents of A is this pointing to there. The contents of A, in other words, is the reference of this array here. So a copy of that reference is being passed into here. Now let me make something very clear. If in somewhere in this method right here there was a change so that this parameter was pointing somewhere else as a result of that, that would have no effect on A. A would still be pointing here. But given the fact that this is pointing here at the same thing that this is pointing at, in other words, array, this parameter, this formal parameter, is pointing at the same place where A, this variable which was passed as an actual parameter, is pointing to. Now when we go through the process of doing the swap, it is actually doing the swap right there in the source data, if you will, in the array itself. We're still making use of this temp variable, which is just a local variable. But when all is said and done, and then this terminates, what's going to happen? Our array is going to have been changed. So this one I think I will show in the debugger. So once again, notice what the output was. I'm going to set my breakpoints. So I've set a few breakpoints. I'm setting a breakpoint right here when I'm about to call swap within the main, and then another one right here when I'm about to call swap first to an array. And then I'm also setting a breakpoint at the end of my swap, and then a few breakpoints in here as well in my swap first to an array. So I'll go ahead and debug it. And here's our variables. We are now in main. Let's see, do I have my call stack? Yeah, here's my call stack. There's main. So that's the only frame on the stack at this point, and this is what it has for its data. And here's args, and args is doesn't have anything in it, but here's A, and A was this array. And see this #99 here? That's kind of like it's not exactly its memory location, but it's kind of its unique object identifier that the Java virtual machine is keeping track of. But this does illustrate that this is some memory location. We're not just primitive data in the frame. It's actually something that's located in the heap. So here we're about to do it. Let's call swap. And now we had just gone through when a copy of the, well, I should say the num1 and the num2, see that by the time at this point, those swap has taken place, as you can see. But the num1 and the num2, if I go back to main, and I look at, it's not num1 and num2, it's A0, A at position 0, still has the 1, and A at position 1, still has the 2. Let me shift my focus back to the method here. They had swapped here, so you can see, and let me go back to the main. Of course, we can see A. It's right here. It hasn't changed. So now let's continue. So now we're about to call swap first to an array, and now we're passing A. If I hover over A isn't the same as A at position 0. A at position 0 was an integer. A is a reference to the integer array. So let's go in there. So we're about to do our stuff here and swap first to an array. The only thing we have at this point before this statement is executed is array, which is actually looking at the exact same place, #99, as A is looking at. So we have a copy. This variable array has a copy of the variable A, which is a reference to that location on the heap. And so now, as we start to proceed, we can see that things actually change. We put a value into our temp. We have now replaced what's in array at position 0, and we have now replaced what's in array at position 1. And if I look at main, we can see that indeed that has taken place in the original A as well. And we'll take it to its final conclusion here, and we can see that in fact they had been swapped. The first thing I'd like to talk about is this concept that's discussed in Chapter 6 about abstraction. And in Chapter 6, they're specifically talking about method abstraction. And later we'll see the term abstraction come up again when we talk about class abstraction. And the idea here is we're separating the use of the method, or at least what we need to know about a method in order to use it, from its implementation, which means how it does it. And really, the only thing we need to know is the header of the method. And we don't need to worry about the implementation. And so when we talk about the header, we're talking about whatever modifiers it might have, what the return types are, the identifier, formal parameter list, that kind of thing. And all we really need to do in order to be able to use it is know these things. We know what it expects to receive from us, and we know what it's going to give us. And we have an idea of what it's going to do just from the sense of maybe what the description of the documentation will show us. So let's think about that in terms of the documentation. We can go to the Java Online documentation. There's your link. I've gone to it before. So let's take a look at, for example, in the math class, the round methods. We have two separate round methods, as you can see, that we're looking at. One is a long, returns a long, and the other returns an int. Remember, that means that these are, well, it's really the argument that's telling us this, that this is an overloaded method. We talked about overloaded methods before. But the point that I'm trying to get at with this is that all we are seeing in the documentation is the header. We see its modifiers, we see its return type, name, parameter list. We don't need to know the details. We do need to kind of have an idea of what it's doing for us, and it's kind of described here. And if we want to go into a little bit more detail, we can see more of a description of what it does for us. But we're not told how it does it. Why should I care how it does it? All I care is that it does it in terms of the user of that method. Now, if I was going to create a method from scratch to do that, of course I'd have to care how it does it. But if I'm just going to use it, I don't have to care how it does it. And that's the whole idea behind abstraction right there, method abstraction. The abstraction of a method is anything that you need to know in order to understand how to use it. And as I said before, later we'll be using this notion of abstraction in the context of classes. So we'll find out, how do we use a class? We don't have to know necessarily, if it's an existing class, the details of how it gets its stuff done. And in fact, a lot of that stuff will be hidden from us. But we have to know enough to know how to use it. And these kinds of things, such as for its methods, whatever their signatures or headers might be, would be important for us to know how to use it. Now, the other thing that they talk about in Chapter 6 that I would like to discuss is the design elements of things. So when we build an application, for example, or a class, that class might have a whole bunch of methods, and each of those methods might be used in multiple places. That's one of the ideas of having methods in the first place. And modular design is to be able to reuse code rather than duplicating it. And so in order to do that, we have to start to get a bigger picture view of things. And we're starting to do that now with methods, with basically taking tasks, modularity kind of thing, where you're taking tasks, where you divide it into these modules. And then tasks may be composed of subtasks, which themselves might be composed further of subtasks. So this modularization of code is where we're going here. And if we're going to draw a picture of that, we can do that using something called a structure chart, or a top-down design chart. And they talk about that in Chapter 6 of the textbook. Of course, by now in your CIS student career, you've done quite a bit of diagramming. You've done some diagramming in the enterprise architecture class, where you've done network diagrams and activity diagrams. And then in your database class, you would have done entity relationship diagrams. And in your systems analysis class, you're doing other kinds of diagrams like use case and class diagrams and things like that. As a matter of fact, we're going to explore class diagrams a little bit here in 331 as well, some UML stuff. Well, here's another kind of diagram, a structure chart. And again, the idea of a structure chart is you're basically trying to depict the overall task broken into subtasks. Those might be broken into subtasks, etc. And from that depiction, you can start to actually build the methods of your application. Sometimes the term that they use for this is stepwise refinement, so that we start thinking about what's the big thing that has to be done, and then we kind of refine it a little bit and refine it a little bit more, a kind of a divide and conquer approach. So let's look at an example, and I'll actually run this example. This is an example from Chapter 6 of the textbook. It's called PrintCalendar. Let me go to the NetBeans and just run it here, and then we'll kind of take a look at it from a design perspective. So here in Chapter 6, we have a program class called PrintCalendar. And it is a program. I mean, it's an application that's going to run. It does have a main method. Classes that have main methods are applications that run. And it also has quite a few other methods. I'm scrolling down here. I can see this. As a matter of fact, one of the nice things that you can see in NetBeans is we can, let me pull up a window that is of interest to you called the Navigator. So I've got this selected, this particular class selected from Chapter 6. If I go to the Navigator, and you can see these are all of the members of PrintCalendar. And each of these members that we see here is a method. And so you can see we have a bunch of methods here, right? And we'll take a look at navigating this a little bit more. But right now I'm just going to run it. And then we'll kind of look and see what Chapter 6 has to say about it. So let me just go ahead and run it. It's going to ask me the year and the month. And then it's going to give me a calendar for that month. So let's make the year 2020. And let's make the month February. And here's my calendar. Notice how it recognized that February had 29 days. And if you look at your own calendar, you'll see that indeed the 1st of February 2020 was a Saturday. Let's see the design. So we're going to see, there's a figure in your textbook that shows the overall design of this. But let's take a look at kind of this stepwise refinement kind of idea by piecemeal showing the top-down design, the structure chart. So here's our structure chart. And you'll see at the top of it is the main method of this class. Well, of course, that's the top of it because that's the starting point. Main is the starting point of our application. And we see two different tasks that are being depicted in this. One is to read the input, and the other is actually to print the month. So if you're really talking about reading the input, well, in this case, reading the input basically had to do with these lines of code right here. So that wasn't necessarily a whole separate method. So a box doesn't necessarily mean a whole separate method, but a box will typically mean a whole separate method, but not necessarily. We could have had a whole method to do all this stuff, making your scanner, getting the full year, getting the number from the user. All of these tasks, all of these little steps, all of these little specific instructions make up this task that they're calling read input. The other task is called print month, and actually there is a method here called print month, and we can see that. So the implementation of this task is here. And then you can already see that print month is calling a couple of other methods too. So let's take a look at that a little spelled out more. So now we've taken this print month, and that's been divided into two subtasks. The month title and the month body. Here's our month title. Here's our month body. Our month body, you can see, is also calling another method. And let's see what happens there. Well, first let's see our month title. Our month title was also calling another method. It was calling this method called getMonthName. So here's our method called getMonthName. And you can see the code for that method. And then in terms of the month body, it's actually making use of two separate methods itself. getStartDay and getNumber of days in month. Let me go back to looking at the code for this. So let me see, getNumber of days in month and getStartDay. And this method called getStartDay itself is calling another method called getTotalNumber of days. And notice that not only is printMonthDay calling getNumber of days in month, but also getTotalNumber of days is calling getNumber of days in month. And that, again, is the beauty of this modularization. where you have some bit of code that can be reused in different places and for different purposes. And that's what we're seeing happening here. And then finally, we have our little method here, is leap year. Remember that Boolean expression that we looked at before for leap years? And similarly, is leap year is used in two different places. So this is an example of a top-down structure chart. This is an example of kind of a way to picture the tasks that need to be done and the breakdown of the tasks into the subtasks, and even the use of particular subtasks in more than one task. Here's one that's used twice, and here's one that's used twice. So back in the Liang samples here, we can again see our little navigator here. Any class is going to have its own navigator. Let me quickly go to another one. Here was another one. See, it's got its navigator with its members. And back to PrintCalendar again. It's got its navigator with its members. I can actually use that to navigate. Maybe supposing I want to see where is this method called getMonthName. Where is its declaration? I'm going to right click on it and I'm going to say go to source. And there it is. See, skips right to it. Another thing that I can say is something like this. Let me go to the is leap year one. I can say find its usages. Where is it used? So I'm going to click on that. And I'm going to ask for its usages, and within the current project is what I'm looking for. I'll find its usages, and there you have it, used twice within the same class. And it's also possible, by the way, for a method of a class to be used in another class, so we could also be finding its usages across classes within the project. So here's the use of this particular method called isLeapYear, PrintCalendar.isLeapYear. And if I double click here, here's where it's used in one place. And if I wanted to look in the navigator, where is it being used? It's being used in get total number of days. And then if I go to the usage again, I see where else is it being used. I'll double click here. And if I go to the navigator, where else is it being used? Is in get number of days in month. So you can see that it had been used in two different places. So there we've seen two different windows, useful windows in NetBeans to help you to navigate your way through your code. The navigator window and the usages window. And for that matter, this idea of being able to go to the source as well, and it takes you right to the line of code where this is being declared. So lots of very useful stuff here. This is probably the most complex application that we've looked at least in terms of how many methods are involved. But we'll be seeing some more applications with this level of complexity as we move forward. The last thing I'd like to talk about is a distinction between two different approaches in terms of your coding. One is a top-down approach, where basically we're setting kind of the skeletal structure of the thing and later filling in details. So when I say the skeletal structure, we are having to declare all of our methods, but not with all the details filled in. And oftentimes, the term that's used for this, a method where you've just kind of sketched it out a little bit, but you're not filling in the details. The term that's often used for this is a stub. And another approach, I'll come back to these slides in a moment, is the bottom-up approach, where we really take on one task and we try to make that work, and then we'll take on another task and try to make that work, and then we'll take on another task and try to make that work as well. And so these are two alternative approaches to implementing our code that we have designed. And really, probably coding is a mixture of the both of them. certainly I would say that in my case, coding is a mixture of both of them. So if we were going to look at this print calendar, and rather than having all the code laid out for each of these methods, notice each of the methods, I mean, you have the body of the method, and if the method is returning a value, you're returning something, maybe just arbitrary, just in order to make it be able to compile and execute. But you're not got the details. So that's the one approach. And of course, the other approach with this bottom-up would really be, rather than putting all the stubs out there, okay, let's tackle the ability to, for example, get the month title and make sure that works. And then we'll tackle the ability to get the start date and make sure that works and all those kinds of things. In a sense, you can think of, to go back to the diagram, that the top-down approach would really be going top-down here, kind of building the stubs, whereas the bottom-up approach might be saying, let's try and make this work, and then let's try and make that work, and then let's try and make that work, that sort of thing. So it's all kind of how you look at it. You want to go top-down, you want to go bottom-up, and as I said, probably for the most part, we're doing a little bit of top-down, and we're doing a little bit of bottom-up. So this has been our foray into methods, in particular stuff that was covered in Chapter 6 and Chapter 7, Methods with Arrays. There's a lot of interesting examples of methods in both of those chapters. One that I'd like to point out to you, here's a class right here, and it has a method called linear search. Notice that this class, however, does not have a main method. So it's not an application class. It's a class that has a method that I might want to use in other classes. Linear search is an interesting one because it takes an array and it takes a value that you're searching for, and it's looping and it's looking for a match, and if it finds the match, then it returns the index value where it found it, and if it didn't find the match, it returns a -1. So if you get a -1 back from your linear search, you know that that particular value is not in the list and not in the array. But if you get something other than a -1, you know that it is in the array someplace. As soon as it finds it, the very first place it finds it, it's going to return the position. By the way, there's other ways to do search. There's faster ways to do search. A linear search is basically starting at the beginning, and it keeps looking and looking and looking until it finds a match. Well, I mean, supposing you have an array that's 10,000 elements long, and the match is somewhere in the latter half of that array, well, it's going to have to start at the beginning and keep looking and looking and looking until it finds a match. On the other hand, if you happen to have your array and it was in sorted order, then you could do something that's a binary search. And a binary search basically says, let's look in the middle. Is it a match, or is the value greater or less than what I found? If it's greater, I know it's in the second half. So let's split that in half. And depending on whether the value is greater than less, then we can go into that quarter. So basically what a binary search is doing is continuously cutting the search space in half until it narrows down on the final result. That's much faster in general than a linear search, although it might be a little bit more difficult to code. So to see those distinctions is kind of nice. What else do we have here? We have a couple of different kinds of sort algorithms. One called insertion sort and another called selection sort. So sorting things is something that is often an important thing to do too. Now, would I code my own sort algorithm? Probably not. There's a lot of sort algorithms in the Java class library that we could be making use of. But somebody had to code that, and so these are two different approaches. If you were taking a computer science class, then you would be doing a lot of these kinds of algorithms, searching and sorting algorithms and things of that nature. But you're not. This isn't a computer science class. Here again is where I would say I want to be able to use it. I don't really care how it works, and I know how I can use it. Look at this. All I have to do, I have to know that it's going to be, it's got a static method, so I would have to call selection sort, the class name dot member name. It's expecting to get a double array as a value. And in this case, it's not returning anything. It's just basically changing the order within that array. As opposed to, for example, the search, which was returning something, right? It was returning an int. So knowing the header, you know how to use the method. And if you feel like experimenting a little bit, I encourage you to see if you can write something that's going to make use of these methods. So as I said, we had done our little stuff having to do with methods in the last few videos. And now in our next few videos, we're going to really start to dive into object orientation. So that has to do with objects 1 and objects 2, and our 2 inheritance PowerPoints as well, and that will be forthcoming.